welcome back to this math class. And today we want to see how to find the HCF and LCM of numbers, and how we can represent the same with Venn diagram. But first and foremost, we want to see how to express a particular number as a product of prime factors. Let's look at the following. You have 48, and you want to express this as a product of prime factors. This is what you do. Look at the first prime number that can go without remainder. How many times do you see 4? In 8, 4. 2 can still go in 4. It's 12. 2 can still go in 12. 6. 2 can still go in 6. 3. Now, 2 will not go in 3 without remainder. Therefore, you go to the next prime number, which is 3. 3 is 1. So if you want to express this as a product of prime factor, so you now see it's 2 times 2 times 2 times 3. So this is times 3. 4 times 2. 1, 2, 3, 4. Okay. So you have expressed this number as a product of prime factors. If you want to write it in index notation, what we do is just count 1, 2, 3, 4. You have 2 raised to the power 4 times 3. And that's all. Now let's look at another one. 84. So the least prime number that can go without remainder is 2. So you have 4 here, you have 2. So you still continue with 2. So if you divide by 2, there will be remainder. So go to the next prime number. And 7, 1. So this is 2 times 2 times 3 times 7. So if you want to write it in index notation, you have 2 raised to the power 2 times 3 times 7. And that's all. That's all. Now, you now want to see how do we now find the HCF and the LCM of numbers. And if you want to find the LCM of, okay, let's first of all find the HCF of 48 and 84. Now, the first method I want to use is what we call continuous division method. So, the number that can go in the 2, the least number, or let me put it this way, the least prime number that can go in the 2 is 2. Then 2 can still go. Since we are looking for HCF, we go for the number that can go into without remainder. So 3 can go. So the HCF, because there's no other prime number that can go except no, there's no other prime number that can go into without remainder. So we stop that way. So we have HCF is equal to 2 times 2 times 3, which is equal to 12. So that's how we can get HCF by continuous division method. Now we want to use the same continuous division method to get the LCM. You look at the number that goes in the 2. That's 2, 4, 2. 2 can still go in the 2. Now, 2 cannot go in the 2 without remainder, especially this one. 2 can go in 12, 6. 2 cannot go here without remainder. So what you will do is, since you are working with LCM, 2 in 12, 6, you write this one down. 2 can still go here. 3, you write this one down. So 3 can go in the 2. So 1 and then 7. So the LCM is equal to 1, 2, 3, 4. 2 times 2 times 2 times 2. Then times 3. Okay, we have 7 here. Times 7. So which is equal to 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3, 48. And 48 times 7, which is equal to 7 times 8 is 56. And 5. 7 times 8, 4 is 28. So add 5. That's 33. 33. So the LCM of this number is 336. That's continuous division method. Now, the next method we want to use is to use what we refer to as prime factor method. So what you do with prime factor method, you write your 48 down, and then you begin to divide it with the least prime number that can go. And that's what leads us to this. So it's better we just write it down so that we can conserve time. So you have 48 with this 2 times 2 times 2 times 2 times 3. That's for 48. Then for 84, you have 2 times 2 times 3 times 7. Now we are looking for HCF. So you now look for the numbers that are common up and down. So we have 2 here. Then we have another 2 here. Then we have 3 here. So 2 times 2, 4, 4 times 3, 12. So by prime factor method, we get 12. By continuous division method, we also get 12. Now, we will now want to get the LCM by the same method. So you get the prime factor of 48 as you have done before, and this is the one. Then prime factors of 84 as you have done before. So the next thing we do, you look at what is the least number. 2 is the least number here. So you have 2 of them here. Then you have 40. So here you have enough 2's to write that one down. So you are looking for HCF. Then 3 is the next one. You have 1 here. So write your 3. Then you have 7. As usual, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. 16 times 3, 48. Then 48 times 7. 7 times 8, 56. Remain 5. 7 times 4, 28 plus 5. So with prime factor method, you get the same answer, which is 336. Now we want to represent this with Venn diagram for clarity, so that you can see the difference or differences between HCF and LCM. Here we have big circle. This one is 48, and this one is 84. So you express 48 as a product of prime factors, which is this one. So you express 84 as a product of prime factors, which is this one. Then where you have the overlapping here, that is where this circle and this circle intersect, is where you have the HCF. So you begin to now say, okay, what is common here? 2 is common to the 2, so you put your 2 here. This 2 also is common here, you put your 2 here. Then 3 is common, you put your 3 here. So here you have the HCF to be equal to 2 times 2 times 3, which is 12. Now for the LCM, we now want to complete the circle. This is 2, 2 here is common here, 2 also is common. Now we have 2, 2 that is left for 48. So we now write those 2 here, 2, 2. Then here for 84, you have 7. So you have 7 here. So for you to find the LCM, in this case, we talk about the union of this circle and this circle, the union. So you write all these numbers out and multiply them. 2 times 2 times 2 times 2 times 3 times 7. So if you multiply this, is 2 times 2 times 2 is 8 times 2, 16, 16 times 3, 48, 48 times 7, 3, 3, 6. That's what the LCM. So if you are given a Venn diagram and you are given any number inside, where it is overlapping, you say, so just multiply the numbers there, and that's all. If you want to get the LCM, then multiply all the numbers together. So that's how to tackle this. So with this, you should be able to understand how to get the LCM and HCF by continuous division method, by prime factor methods, and then how we can represent the same of Venn diagram. So this is where we will be stopping until I come across you again.